All righty, let us get started. So today we're doing the exam review for our exam on Friday. The last test we'll be having before final exams. Friday, of course, is the test, so that'll be posted onto Canvas just like the previous exams were. Format will be the same way. Posted to Canvas in the morning. You download it. You can either work out all the problems and everything on the test itself or on a blank, separate sheet of paper if you'd prefer. And then you submit it back to Canvas. The deadline would be 11:59 p.m. that night. So you'll have the full day to work on it. And that gives you the best opportunity, whether you have, obviously you probably have other classes during the day and all of that stuff. So if you want to wait till you get back home or whatnot to start to work on it, that's fine. Just as before, you are allowed, of course, to use your notes, to use any of the materials, the resources we have on Canvas for the class, look over the videos, whatever you'd like. The only thing you're not allowed to do is to work with someone else, copy someone else's answers, things like that. You have to do your own work out your own tests, solve the problems, and answer them for yourself. But like I said, look at your notes, look at the practice problems that are on Canvas, however you want to do it, to do the best job you can working these problems. If, of course, you have any questions about the test, for instance, I can't really read what this number is, or, hey, it looks like maybe there's a piece of information missing in this question, things like this, definitely send me an email. And if there is something wrong, of course, I will send an email to everybody to give the information that may be missing. Or if there's not really missing information, you can actually solve the problem the way it is, then I'll let you know that as well. The only types of questions I'm not going to answer are the kinds of questions like, hey, can you look to see if my particular answer for number 4 is correct? I can't do that kind of thing. You have to submit the test before I'm allowed to look at it and judge whether any of the answers look okay. And just as before, definitely show all your work. That way, if there is an issue, the question, the answer is wrong, maybe you have radian mode on your calculator, at least I could give you partial credit because you've shown you know how to solve the problem. It's just there was an arithmetic mistake or something like that happened. So show all your work. If you don't show your work and all you have is an answer there, then I have no idea if this is actually your answer if you copied it. I need to see your work to be able to give you credit for these things. All right, so just like before with all of these kinds of exam reviews, I'll go over what are the topics you can expect for this test. Well, everything since the last test we had, which means it's on all of light and optics. This is the major overarching subject matter we discussed. And I guess the best way to handle it is to think of it as breaking it down into 3 parts. The first part was about waves and light specifically. And with this, we talked about the different types of waves, transverse, longitudinal waves. There's water waves, sound waves, light waves, all these types of different waves. And what is common to all waves? What are the various characteristics that are important for waves? And so we know, first of all, the first big equation is the relationship that tells you velocity, the velocity of a wave, how fast a wave propagates through its medium, is the frequency of the wave times its wavelength. Okay, that's the first big equation. All the 3 big characteristics of any wave that exists are given in this relationship. And of course, if we're talking about light, then we know light has a very specific velocity, the velocity of light, called c, which is 3 times 10 to the 8th meters per second. Or at least this is the number we will use. But of course, other waves have different velocities. The velocity of sound in a vacuum is 343. Velocity of water waves is whatever they are. Velocity of waves in a string, of course, depends on various things, how tight, the tension in the string and all things like this. But specifically, light has a very special velocity, and this is a number you need to know. 3 times 10 to the 8th meters per second is the speed of light. It's a very important number. Now, there were some other characteristics. For instance, we had things like the period of oscillation is 1 over the frequency. And if you remember, the period is kind of like the frequency being the number of oscillations the wave contains per second. Okay, so if you measure in 1 second how many times the wave oscillates, that's the frequency. The period is kind of the opposite. It says, if I look at just one oscillation, how long does that take? How many seconds does it take to make one oscillation? So frequency and period are related very strongly. Period is the inverse of the frequency. And then the other big equation was the functional form of a wave. That is a mathematical equation which contains all the information you need to know about a wave. And if you remember, it went like this: y, which stands for what is the height of a wave at a specific point at a specific time, is equal to a, which is the maximum amplitude, the maximum height the wave can ever get, times sine of kx minus omega t. And here, there are 3 real characteristics you need to know, and that's a, the max amplitude, k, which is called the wave number, and what it is it's related to the wavelength. It's actually 2 pi over the wavelength. And then omega, which is called the angular frequency, which of course is related to the regular or the linear frequency. And it is 2 pi times f. And so if you could write down this mathematical equation, given all these numbers in it, then you basically have an equation which defines a particular wave. And thus you could do some analysis. You could predict. If I look at some position x at some time t, which are numbers you would give the problem, then you could figure out what the height of the wave is, y, given you know all this stuff. And so a problem would be something like a wave traveling at 300 meters per second has a frequency of 500 hertz and a maximum amplitude of 2 meters. Write down the functional form of this wave. And so it'd be your job to take that information from the problem, figure out what is A, what is omega, what is K. So you probably have to do some calculations to get them. And then once you have them, you write down this formula, plugging in the numbers for A, K, and omega. X and T, remember, they're just variables. They're the things that if you're actually doing an experiment, you would put your own numbers in for that. The problem doesn't give you those numbers. The problem gives you the A, the K, and the omega, or it gives you information to be able to find A, K, and omega. And so that's the first big topic. Waves and light in general. All waves, these are the very special characteristics. These are the important equations we're going to worry about, and we need to know how to be able to work with them. From there, we went on to polarization. And so now we're talking about light specifically. And we were told that the polarization of light is a characteristic of light. All light has this characteristic, even though we can't physically see it with our eyes. It is a characteristic that exists and can be detected by other means. And what is it? It is the direction of oscillation of the electric field. So if you remember, we figured out light. What is it made of? It is the oscillation of an electric and magnetic field as it propagates throughout space or throughout whatever medium we're talking about. So there's an electric field oscillating, and then because the electric field is oscillating, it's making a magnetic field oscillate as well. And so that magnetic field makes the electric field oscillate, and it just keeps messing with each other as the thing moves along. Now, which direction the electric field and magnetic field oscillate is, it doesn't matter. It can be any direction. What is true is that whatever the direction of the electric field is, the magnetic field is perpendicular to it. So for instance, if the electric field is up and down, the magnetic field is left and right, or back and forward. But the electric field doesn't have to be up and down. The electric field could be left and right. And so the magnetic field would be up and down, and so forth. And so the direction of the electric field, whatever direction it is for this particular light, that's what we call the polarization. It's polarized upwards. So the electric field oscillates up and down. Or it's polarized to the right. Then I would say the electric field is oscillating left to right. And of course, at any angle, it could be polarized at a 30-degree angle. So that means the electric field is oscillating 30 degrees. So every light has some polarization. And what we'd like to do is say, because we know we can produce materials called polarizers or polarizing filters, which can block light if the polarization of the light is not in the same direction as the polarization of the filter itself, or let light through that is in the correct direction. Well, maybe we want to know, what if we set up all of these filters and we send this light through it, how much of the light will make it through and how much would be blocked? This is what's called the law of malice. And it says the intensity of the light that makes it through a polarizer is given by the initial intensity of that light. So if this is an actual experiment, you would know what this number is, 5,000 or whatever. But for us, we're not going to have a number for this. So we're just going to leave it as the variable I naught. We're not going to put a number there. We're just going to leave it as I naught. So it's I naught times the cosine squared of some angle theta. And theta, this angle, it's tempting to want to say, oh, well, given a problem, you start with a polarized light, and we're going to send it through a polarizer who's polarized at 30 degrees. Well, 30 degrees is the angle. But that's not true. This angle is not the angle of the polarizer. It's not the angle of the light. What it is the difference between the polarization of the light and the filter. And so a typical example looks something like this. Here's light polarized up. Here's a filter that's polarized at some angle. Let's say it's 30 degrees. For this particular example, I want to know what intensity of this light will make it through this filter. Well, it's I naught times cosine squared of theta, where theta is the difference between the light coming in, which for us is 90 degrees, because it's vertical, it's upwards, and 30 degrees, which is the filter. And so we say 90 minus 30, that gives us an angle of 60 degrees. And so we would say, I believe this is probably 0.25 times I naught. That's how much of the original light makes it through. 25%, a quarter of the light will make it through. And so it's very important to know that this angle theta is the difference between the light coming in and the light going, what it's trying to go through. And then we extend it further by saying, okay, well, what if we have multiple filters, not just one? If we have 2 or 3 or 5 filters, how do I handle it? And the good news is it's really easy. For every filter, you have a cosine squared theta, and you multiply them all out. So if I had a second filter on this example, I would say the answer is I naught times cosine squared of 60 times cosine squared of the next angle. And remember, the angle, once the light makes it through the first filter, that light is no longer at 90 degrees. Now the light is at 30 degrees because it made it through the filter. And so it has to be at that angle. So whatever the second filter is, let's say it's horizontal, then I would say, okay, now my light is at 30. I'm trying to go through a horizontal filter, which is 0 degrees. So 30 minus 0 would be 30. So then I'd have a cosine squared 30 after this. And in multiple filters after that, you multiply more and more cosine squared thetas. Multiply them all out and you get your final answer. The other note is, what if I have unpolarized light? Well, this is, first of all, a very bad name, because I already said light, all light is polarized in some way. And so there's no really such thing as unpolarized light. What we mean is it's randomly polarized. Sometimes it's up, sometimes it's horizontal, sometimes it's at 71.5 degrees, whatever, it's all random. And so if I start with this unpolarized light and I'm trying to go through a filter, how do I handle that? And remember, what we do is the first filter does not give cosine squared theta, but rather just 1/2. And an example of this looks like this. First of all, the unpolarized light symbol that I use is this symbol here. So instead of the light being in a particular direction, I have this kind of cross direction thing to say it's unpolarized. And then I'm trying to get through a series of polarizers. Let's say these two. This guy is at 60. And this guy is at 45. Well, for this example, I would say, okay, the answer, just like before, I naught cosine squared theta. Well, to go from unpolarized light to the first filter, it's purely just 1/2. No cosine squared theta. That's it, just 1/2. Then the light is now past the first filter and it's now at 60 degrees. That's what this little yellow arrow means. It's my own way of reminding myself I've moved past the first filter. I'm now going to the second one, and my light is now at this particular angle. The unpolarized light made it through the first filter. So what's left is this yellow arrow, and his angle is whatever angle the filter was, which is 60. So now that 60 wants to go through the 45. I'm not unpolarized anymore, so now I have to have a cosine squared theta. What's the theta? Well, I'm at 60. I'm trying to get through 45. So 60 minus 45 is 15. And now I've made it through the system, and I could calculate my answer. So I go into my calculator, do cosine squared of 15 times a half, and I get 0.467 I naught. And so that's the special case. If instead of our light starting polarized, it starts what's called unpolarized. The only difference, I work it the same way, except the first filter, regardless of what his angle is. His angle could be 90, it could be 0, it could be 50, it doesn't matter. The first filter is just a half. Once you're past the first filter, your light is now polarized at this new angle. And so from then on, you do cosine squared theta for every other filter. And that's it. That's polarization, at least the type of polarization problems we're doing. You're given light in a certain direction. You're given a system of polarizers. And you want to find out the intensity of the light that makes it through the system of polarizers. You use this law of Malice to do it. Finally, the last thing we had was refraction. And refraction, the big thing is Snell's law. Snell's law says N1 sine theta 1 is N2 sine theta 2. And this goes for the type of problem where you have light coming in, hits the surface of a medium. So maybe you're going from air to water. So you've got two different materials. Your air is starting in one, trying to go to another. The light hits the material at some angle theta 1, and then bends in some way to some new theta 2 when it reaches the new material. And the question usually says, calculate the angle of refraction. And what that means is, what is the angle of the light in the new material? The second angle. And so you use this equation. You know the materials that are there, so you know the index of refraction for each material. You're given the initial or the incident angle, the light coming in at a certain angle, and you want to find the angle going out. And it's purely just this equation. And of course, if you have multiple layers, so maybe you have 3 materials instead of just 2, well, then you just have a Snell's law for the first set of materials from the first to the second material. And then you have Snell's law for the second to the third material. So still just Snell's law, but if we have 3 materials, you have to do it multiple times. Yeah, there's a question.
Yeah, my question was about the polarization.
Yeah.
You didn't do a problem with the one going to the right, like the arrow to the right. I know it means 0, but when I was doing the homework, I was kind of confused on how to like go through that kind of problem because I didn't know how to, I don't know how to explain it, but could you just go over the one with the 0 degrees?
Sure. Now, are you asking if the light starts at 0 degrees or if one of the filters is 0 degrees?
If one of the filters is 0 degrees.
Okay, yeah, no problem. Let me do an example really quick. So here's an example of polarization. Let's say we have light. The light starts polarized up. Then we have, let's say, what am I doing? Then I have here 60. Then I have here horizontal. And then I have here 30. Oh, yeah, I did it again. Arrow. What am I thinking? Apparently my brain's not working too well. There we go. Here's my problem. One of the filters happens to be horizontal, but that's okay. This is my problem. What's the intensity of the light that makes it through? I is I naught cosine squared theta. So we start with I naught. That's the initial intensity, whatever it is, I naught. First thing, we're going from 90 because we start vertically and we're trying to get through this first filter. So I have a cosine squared, and I'm going from 90 to 60. So 90 minus 60 gives me 30 degrees for him. I've now made it through. My light is now past that guy, and he's now at 60 degrees, just like the filter was. And now that light is trying to go through the next filter, which is horizontal. And horizontal means 0 degrees. So we have another cosine squared here. The angle for him, I'm at 60, trying to go through 0. So 60 minus 0 is 60. I've now made it through that filter. So now my light is past. He's now at the new angle of 0. And now I want to get through this last filter. That guy, of course, has another cosine squared, theta. We're at 0. We're trying to make it through a 30. 0 minus 30 is 30. And now that's what my equation looks like. Each one of the filters gives me an angle. The angle, of course, depends on what's the light already at and what's the filter at. So the first filter was 90 minus 60, which gives me 30 degrees. The second filter, I'm now at 60 because I made it past the first filter, and I'm trying to go through a 0. So 60 minus 0 is just 60. Now I've made it past him. I'm now at 0 because that was that guy's filter. And so now I'm trying to go from 0 to 30. 0 minus 30 gives me, of course, negative 30, but I already said in a previous lecture, don't worry about negative angles, just make them positive angles because it's the same number. So I put 30. Okay, so how does that look?
Okay, I understand that. Now my next question is, if the first one is like the one that's the 0 degrees, do you just...
Yeah, okay, now I see. Now I see the issue. What if we have this right here? Horizontal, maybe 60 degrees, and maybe 45. So now we have this one. Okay, again, 3 filters. One of them happens to be horizontal, but no big deal. And so we were to go past and do this. Now, I'll do it 2 ways. I'll do it the normal way you're supposed to, and then I'll do it the shortcut way. So the normal way, same exact process. I is I naught, cosine squared theta. So we have I naught starting. Now, first, we're going from 90, trying to get through the first one. The first one's at 0. So we have a cosine squared, and we're going from 90 to 0. 90 minus 0 is 90. We're now past him. The light is now horizontal at 0. And so I have another cosine because I'm trying to get through a second filter. I'm at 0, trying to get to 60. 0 minus 60 is 60. I'm now past him. I'm now at 60 degrees. And I'm trying to get through this last filter. So another cosine squared. 60 to 45 is 15. Okay. And so this I would plug in my calculator and get an answer. Now, I could tell you the answer without actually getting my calculator out. I can tell you the answer is 0. And the reason the answer is 0 is because there's a little trick with polarization. And the trick is this. Anytime light is polarized perpendicular to a filter. Okay, so in this case, I'm upwards polarized at 90, and the very first filter is horizontal. Well, my light is perpendicular to the first filter. Anytime you have light polarized perpendicular to a filter, no light will ever make it through. All of the light is always blocked. The only time you could get light making it through a filter is if it's polarized at some angle, any angle other than perpendicular, other than 90 degrees. So for all of these things, we're at 90, the filter's at 60, so there's a 30-degree difference. That's perfectly fine. We're at 60, we're trying to make it through 0, there's a 60-degree difference, that's fine. If the difference is 90, so we're perpendicular, then we have an issue the filter blocks everything. And in fact, this first term right here, cosine squared of 90, cosine of 90 is exactly 0. So it doesn't matter what any of these things are. Whatever those numbers are, you're multiplying it by 0. So the trick is, if you see in one of these problems where the one step to the very next step are perpendicular to each other, then you don't have to do any of the calculations. You could just say it's 0 because it's perpendicular. Now note, that's not true here. Here, it's not 0. And the reason it's not 0, even though we have perpendicular right there, there's something in the middle. There's something between them. That first filter changes our light to not be vertical anymore, but now at 60. So even though you would think, well, here to here gives me 0, why doesn't it give me 0 there? That is our normal, real world, everyday way of thinking, which is completely logical. You would think it should give you 0. If this blocks everything from this guy, then shouldn't this block everything from this guy, no matter what's in between them? Yes, it should, but it doesn't. These things, the way this light polarization is working with these filters is very strange. And so we can't use that logic. The logic we have to use is from one step to another. So here's the first step, here's the second step, that with nothing between them, they're perpendicular. That means the answer is automatically 0. Here, the first example, there is a perpendicular thing, but there's something between them. So it's not one right after the other. All of a sudden, I can't say it's 0 anymore. I have to do the calculation. Okay, so does that make a little more sense?
Yes, it does. Thank you.
Sure. And by the way, that also counts if I have something like this. Let's say this guy, then I have this guy 45, then I have this guy at 0, and then this guy vertically. Well, that's a bad vertical. That doesn't look vertical to me. Like that. I could say this is 0. I don't have to do the calculation. And the reason is because from here to here, one step to the next with nothing between them, it's perpendicular to each other. So even though the original light goes through the first filter is now at 45, that's fine. This step is the step that blocks everything. Going from purely horizontal to purely vertical in one step automatically blocks. So it works if your first step is like that, and it works for any steps that are like that, as long as what we're saying is perpendicular with nothing in between. Now, if it's confusing, or if you're afraid, oh, I don't really know if I can trust whether it's always 0 or not, well, don't worry about it. Just do the actual calculation, and your calculator will make it 0 for you. If I didn't know I could just make this 0 at the beginning, I would type all of this stuff in my calculator and it would tell me 0. So that's the good news. If you always just follow the law of malice without thinking, you just, crank it like a machine, you'll get the answer correct no matter what. However, if you like to save time, if you're very comfortable with this stuff and you see, look right here, these two steps are perpendicular, I don't have to waste my time doing a calculation. I could just call it 0. You're more than welcome to do that. All right, so back to refraction. Snell's law. Light coming in one medium, hits another medium, goes to a new angle. Perfectly fine. If we have 3 layers or 4 layers or more, then you just use a Snell's law for the first 2, and then Snell's law for 2 to 3, and then Snell's law from 3 to 4, and so on, till you get whatever answer you're looking for. The other thing about Snell's law or refraction is the concept of critical angle. Critical angle is a special case of refraction when you're going from a more dense medium to a less dense medium. So water to air. Water is more dense than air, it's thicker, or glass to water is another way. If the index of refraction is bigger, it's more dense. So if you're going from more dense to less dense, there's a chance of what's called total internal reflection. That is to say, if you have light, hits the surface, and instead of going through into the next material, it just bounces back. Okay, that's total internal reflection. Now, how do we know what angle this happens at? Because if you have too small of an angle, the light will make it through. Too big of an angle, it'll reflect. The critical angle is that very specific number where anything bigger reflects, anything smaller goes through. How do you find it? You just do Snell's law. N1 sine theta 1 is N2 sine theta 2. However, theta 1, we now call it critical angle, the thing you're looking for, and theta 2 is defined as 90 degrees. Because at the critical angle, what happens, it comes in, hits the surface, and then just skims the surface. So the light doesn't make it into the air or whatever, it skims the surface. And so the angle that the light makes with the air is 90 degrees. And we want to know what angle does this occur at. That's called the critical angle. So either way, whether we're doing a normal refraction problem or we're doing a critical angle problem, you use Snell's law, and depending on which question it is, you're either solving for the angle of refraction, which is theta 2, or you're solving for the critical angle, which would be theta 1, with theta 2 being 90. And that's refraction, at least the amount of refraction. Yeah. Question.
What's that on the right? The T.
Yeah,
something?
it stands for total internal reflection. So T for total, I internal, R reflection. Total internal reflection. That just means if you shine light at a big enough angle, the light reflects back into the surface or back into the medium. It doesn't leave. If you're underneath in underwater in the swimming pool and you shine a laser pointer at 70 degrees, that angle is big enough where the surface of the swimming pool acts like a mirror. And so the laser pointer reflects back down into the water. It doesn't leave into the air. That effect is called total internal reflection. But the critical angle is right before this reflection starts. So it just barely skims the surface.
I have a question.
Sure.
With N2, with the critical angle, I mean the angle that's skimming the surface,
Yeah.
would that be, I'm a little confused on that. Would that be 1 or will be given to us?
Yeah, that depends. So it depends on how the question is asked. If the question is, calculate the critical angle for water, what the question is implying to you is you're shining light from water and it's trying to go into air. So N1 would be water, N2 would be air. Okay. If, however, the question says, find the critical angle for glass, if the light is traveling from glass to water. Well, now what I'm saying is you're in glass, so N1 is glass, and N2 is not air, rather N2 is now water, because the question said it specifically. So if the question doesn't say it specifically, if it says calculate the critical angle for glass, then you're to assume, okay, first material is glass, second material is air. Now, the values of N1, N2, what are these N's? Those values will be given on the test. You don't have to memorize that the critical angle for air is 1, critical angle for glass is 1.5. Those will be given on the test. But Which material are we talking about? That would depend on the particular question. As I said, calculate the critical angle for glass means N1 is glass and N2 is air. Okay.
Oh, thank you. So whenever we have to calculate the critical angle for something, that's where it's going to be our N1 values.
Theta 1. Yeah. Critical angle is theta 1. It is what is the angle you're shining the light at to make theta 2 90 degrees. That's basically what it means. So you would plug in N1, you'd plug in N2, you'd plug in theta 2 is 90, and you calculate what is theta 1.
Yeah. Okay, thank you.
Mm-hmm. Any other questions? Any questions in general about the test? Because that's all the topics, right? So we had basic wave and light, some equations about, characteristics of waves and things like that. Then we have polarization. Light is polarized. We try to send it through a filter. We use the law of Malice. And refraction, Snell's law. Light travels from one medium to another, changes its path. How does the path change? Those are the three big topics. As is usual, this test will be given as if it's an in-class test, so it's a 1 hour long test. I'm not making it longer because it's a take-home test or anything. And as you've seen in the past, usually it's about 6 or 7 questions, all calculation style. So we have 3 big topics. There's probably 2 questions per topic. Polarization is a little weird because the way I usually do polarization is there's a page, question 3 is polarization. And there's A, B, C, D, E. For each A, B, C, D, E, here's the polarizing filter system, what goes through. For part B, here's a new system, what goes through this one, part C, and so forth. So it's one big question, but like 5 parts. Each part is its own little system. But other than that, you could think probably 2 or 3 refraction problems, 2 or 3 light and wave problems, and probably 1 big polarization problem. Okay. So, no, I was just going to ask any questions about this.
Will you be uploading the lectures for 27 and 28? I want to go back and look at it again.
Yeah, I believe there may have been an issue with one, the one on Monday. I think it cut me off after a few minutes, and then I came back. And for whatever reason, the second half of that particular lecture didn't record by Zoom. The first half did, but the second half didn't. I don't know why. So that particular one, I don't have the last half when I came back, but I can put the first half in, no problem. And any of the ones I have that weren't already uploaded, they will be uploaded for sure. And if it's not uploaded, if you're trying to look at it really quickly, there's also the previous year's lecture is on Canvas as well with the same material. So you could look at those. I'm doing the same things. I may say it slightly differently because I don't write any of these notes down. I just talk. So you could also use that as an extra resource to look at too. But yeah, I'll post those. And today and tomorrow, I'm working on grading all the homeworks to make sure that the homework that you've turned in for this optics stuff, you'll be able to take a look at before the test. So that'll be posted as well. And these kind of written notes too, those will be posted. Yeah, for sure.
Thank you.
Sure. Any other questions about this test?
I have another question for the polarization.
Okay.
So what about if I don't remember what you said the difference was. Like basically the first one, like on the screen, how the first one is the 90 degree and then the other one is the one going both ways. If the first one is just the arrow to the right, it would just be 0 starting off.
That's exactly right. Yeah. For whatever reason, I don't know why my brain does this, but I almost always make the original light 90, but it could be anything. I can start with light like this. I could say the original light starts at 30. and this guy is up, and this guy is 45. I could do something like this, okay? There's no difference. The only difference really is when you go do the calculation and you have I is I naught cosine squared. The angle, well, what's the original light? It's 30. This light is 90, so 30 minus 90 is 60. Now I'm vertical. I'm going through the second one, cosine squared, 90, trying to go through 45. 90 minus 45 is 45. So exactly what you said. Whatever the starting light is, it can be 90, it could be 0, it could be 20, it doesn't matter. What you use it, what you do with it is when you do that first filter and you're doing the difference between the angles, well, instead of starting at 90, now you're starting at 30, or you're starting at 0, and you're trying to get to the first filter. Okay. Does that make sense?
Wait, can you explain it again?
Yeah. So if you notice for all of these, I always start at 90. And so the very first filter, like for this example at the top here, I'm going from 90 to 60 is an angle of 30. But the light doesn't have to start vertically. It could start at any angle, just like all the filters can be at any angle. So for this example, I started the light at 30 degrees instead of 90. Well, the process is exactly the same. It's still the law of malice. The very first filter, I'm going from 30 to 90. So the theta for him is 30 minus 90 is 60. If the original, all the other examples would have started like this instead. Right? I start at 90, I'm going to 90. So this guy would be cosine squared of 90 minus 90, which is 0. And now I'm at 90 and I'm trying to go through the next guy and he's 45. So this is the difference between these two. Here my light starts vertically polarized. Here my light starts 30 degrees polarized. All that changes is what is the angle you use for the first filter. How do you know what angle to use? It's the same rule we've been using. What's the light currently at? For the first thing, it's currently at 30. What's it trying to go through? It's trying to go through 90. So 30 minus 90 gives me 60 for the top example. The bottom example, what's the light currently at? It's currently at 90. What's it trying to go through? 90. So 90 minus 90 gives me 0 for that one. So whatever the starting light happens to be at, that's the starting angle. It doesn't have to start at 90. It doesn't have to start horizontally at 0. It could start at any angle we wanted to. And so you just think about the rule. The rule is when I go plug my theta in for cosine squared, I ask myself, what is the light currently at? In the top example, it's at 30. What is it trying to get through? A filter that's at 90. So 30 minus 90 is 60. Okay.
Okay, so the question the one to ask about is from the station homework, and the first two were 0. The third one was 30, and the fourth one was 45. So what you're saying is I would have to have for the answer, the first one would be 30 degrees because I'm going to just subtract the 0 degrees from the 30, which is the first one. And then I would do the 30 from the 45, which would give me the 15.
Let me make sure I understand what I remember the number. So you said the starting light is horizontal, you say?
Yes.
And then the first filter is?
It's horizontal also.
Okay. And then the second filter?
30 degrees.
30 degrees. Okay.
Then 45.
And then 45, sure. So for this one, what I would do is I would say, okay, I naught the very first one, cosine squared of what? Well, my light is currently at 0. What am I trying to get through? This guy is currently at 0. So 0 minus 0 is 0. So that's the first one. Now my light is horizontal. And I'm trying to get through the second filter, which is 30. So now I have another cosine squared. He's at 0. He's trying to get through 30. 0 minus 30 is 30. Then he's now at 30. He's trying to get through this last one. So another cosine squared. 30 minus 45 is 15. So that's how that one would look. So the first filter you still have to do. It happens to be the same angle, so cosine squared of 0 is just 1, so it happens to doesn't matter, but every filter gets a cosine squared. The theta is what's the light starting with before it hits that filter, and what's the filter at. So for that particular example you asked about, it started at 0, the first filter is at 0, 0 minus 0, the first cosine squared is cosine squared is 0. Then for the second cosine squared, now we're trying to get through the 30 guy. He's at 0, trying to get through 30, so 0 minus 30 is 30. And so on down the line. Does that clear it up?
Yeah, thank you so.
Cool, cool. Any other questions? All righty, well, if you do have any questions that pop up as you're studying, you're always welcome to email me as usual. If you have a particular problem you're trying to do and you're unsure why you're getting the wrong answer or whatever, take a picture of it, send it to me in an email, and I'll look over it and see what's going on. And definitely look at the practice problems on Canvas. The solutions are there as well. You can see me having worked out particular problems if there are any issues you're having. But basically, you know what the tests look like by now. You know what to expect. So as long as you practice these problems, there shouldn't be anything on the test that'll be surprising to you. But then I will send an email when the test is posted on Friday, in the morning, of course. And then you'll have the full day to work on it. Definitely submit it before 11:59 p.m. And if there is some issue or something, email me and let me know, and we'll resolve whatever needs to be resolved with that. Other than that, you are free to go. And I wish you luck with the test.
Thank you.
Thank you. Have a nice day.
All right, you too. Thanks.